Hello viewers, welcome back to my channel, Math Made Easy with PDY. In today's lesson, we are just going to revise a little bit on the topic indices. Without wasting my time, what are we supposed to revise on? We should be able, by the end of this lesson, to state at least 3 laws of indices, and then 2, you should be able to use the laws of indices to evaluate mathematical statements. Now, to begin with, someone may ask, what then is indices? Now, you realize that we actually deals with powers of numbers, and we only have powers of numbers when we have the product of numbers multiplying themselves as many times. So, for example, we may have 2 multiplying 2 multiplying 2. This can be simplified and written in an exponential form, which is 2 exponent 3. Likewise, you may have a multiplying a multiplying a multiplying another a. This can also be expressed as a raised to the power 4. So, dealing with powers of numbers, then we say you are actually talking about indices. Now, when you have any expression written in the exponential form or the number form, such as we have a to the power 4 as you've just seen, the number 4 represents the power. In other words, you can also say that it is the exponent, and you can also call it the degree. Then the value a is classified as the base. The base. Some other books may have other names for them. So you can also say it is known as the index. Therefore, when you are dealing with more of these powers of numbers, we say you are dealing with indices. So I will also say that indices is simply the plural form of powers of numbers. We just classify them as a plural form of it. So therefore, we are just going to work with powers of numbers. And as I said early on, powers of numbers only come on board when you have a continuous multiplication of that number. Remember that powers of numbers are established when you have a continuous multiplication of the same number. Therefore, since we are going to deal with manipulation of powers of numbers, and for which we have powers of numbers being established when they multiply, then we have some laws or some rules that can make us find it easy to manipulate powers of numbers. Now, the first rule we are going to consider, or some other books may say the laws of indices. The first law we want to consider is the product law. Then someone may ask, when do we have the product law? When we have a number, let's say 2 multiplying 2 raised to the power 3 multiplying 2 raised to the power 4. This expression can be written as 2 raised to the power 3 plus 4. And hence, we simplify it and have it as 2 to the power 7. Now, why is it so? If I have 2 raised to the power 3, I can expatiate it and write it as 2 times 2 times 2. Likewise, 2 raised to the power 4, it can also be written as 2 times 2 times 2 times 2. Therefore, multiplying all the 2's, then how many 2's are we multiplying? There are 7 of them. That is why we say that 2 multiplying 2 raised to the power 3 multiplying 2 raised to the power 4 can be simplified, and then we have 2 to the power 3 plus 4. And generally, it works for all product of exponential functions with the same base. It works for all, and therefore it became one of the laws of indices, which is the product law. So we can finalize that when you have any number raised to a given power, let's say m, multiplied by the same number raised to another power n, you can simplify it and then write it as a to the power m plus n. And that is a product law. Now the second law we can actually look at is the quotient law or the quotient rule. And what do we mean by the quotient rule? If I have 2 to the power 4 divided by 2 to the power 3, now mathematically, the law states that when they are having the same base, then we can write it as 2 to the power 4 minus 3. And that gives us 2 to the power 1. And that's the same answer as 2. Someone may ask, how come that division changes straight to subtraction? Now, when we go in another form, when we have 2 to the power 4, we can write it as divided by 2 to the power 3. And we know that we can expand 2 to the power 4 as 2 times 2 times 2 times 2, all divided by 2 times 2 times 2. Now you realize that we've written them in a factor form, so common factors can be dealt with. So 3 of the 2's for the numerator can deal with 3 of the 2's at the denominator, and it will be left with only 1 of the 2. So we say that 2 to the power 4 divided by 2 to the power 3 is the same as the value 2. And you could have also done it using the law, and that is dividing 2 exponential functions with the same base. You can simply maintain the base and then subtract the powers, and you end up getting the same answer. So the next law we've established is that when I have any number to the power m divided by the same number to the power n, we can simplify it and write it as a to the power m minus n. Now moving on to the third law, if we have the number 2 raised to the power 3 all raised to a power of 2, now the law states that if you have a bracket separating 2 exponential functions, you can also multiply them. Therefore, it's going to be 2 to the power 3 times 2, which gives you an answer of 2 to the power 6. Now we can also explain it using another idea, which is if I have 2 to the power 3 all to the power 2, we can expand it and write it as 2 to the power 3 multiplying 2 to the power 3. Or because when you have a function raised to the squared power, then it means that we can split it twice. And therefore, we can go back to our first law, whereby we state that when you have the multiplication of 2 functions which have the same base, you can actually add the power. So having the base as 2, we can have it as 2 to the power 3 plus 3. And that still gives us an answer of 2 to the power 6. So far, that is the third law. So you can simplify by saying that if I have the number a to the power m all raised to the power n, we can simplify by saying that it is a to the power mn. Moving forward, we can come up with some other properties of indices, which includes basic indices expressions such as if I have any number, let's say 2 to the power 0, it gives us an answer of 1. Or any variable a to the power 0, it also gives us an answer of 1. Why is it so? I can just use a simple expression to define that. This is what it means. If I have the number 2 to the power 3 divided by 2 to the power 3, now this is going to be 2 multiplying 2 multiplying 2 3 times, all on 2 multiplying 2 multiplying 2. Therefore, you know, each factor can go into itself 1. So at the end of the day, the numerator will be left with 1 on 1. So finally the answer is 1. So when we bring it to the laws of indices, if I have 2 to the power 3 dividing 2 to the power 3 using the law, since the bases are the same and they are dividing, then we need to subtract the power. So we have 2 to the power 3 minus 3, which gives us an answer of 2 to the power 0, and that gives you the answer as 1. So note that this is a property which you can use in simplifying indical expressions or expressions written in their index form. Also, we have 2 to the power 1 is the same as 2, or any number to the power 1 gives you the same number, A. You can also explain that using a basic expression such as if I have 2 to the power 4 divided by 2 to the power 3. Then we can expand the numerator to have 2 times 2 times 2 times 2 4 times, all divided by 2 times 2 times 2. Now, 3 of the 2's at the denominator can do away with 3 of the 2's for the numerator, and it will be left with 1 times 2. So our final answer is going to be 2 on 1, which is the same as 2. Now we can use our law, the quotient law, which is if I have 2 functions, exponential functions dividing, so 2 to the power 4 divided by 2 to the power 3. The bases are the same, so I can simply work with the powers by subtracting. So 2 to the power 4 minus 3, that gives us a final answer of 2 to the power 1, which is the same as 2. So that is another property of indices we need to also bear in mind. We are going to use some of these properties to solve some other work examples, examinable work examples that have actually been given some time ago. So let's go to some of the other properties. That is the negative exponent. If you have a negative exponent, how can you write it? In what form can you also write it? So if I have the number 2 to the power negative 1, it can be written as a fraction, which is 1 on 2. Likewise, if I have a to the power negative 1, it can also be written as 1 on a. And you can extend this to a to the power negative 2. You can express it as 1 over a squared. Then it goes on and on and on. Now, this idea is explained using basic expressions such as, say, we have 2 to the power 2 all divided by 2 to the power 3. Now we can expand this. The numerator becomes 2 times 2, all on 2 times 2 times 2. Now when we break it down into its simplest form, 2 of the 2's for the numerator will do away with 2 of the factors for the denominator. So it will be left with the numerator of 1 all on 2. And when we go back with our exponential, the quotient law, you realize that having 2 to the power 2 divided by 2 to the power 3, now we can simplify that 2 to the power 2 minus 3, and that gives us an answer of 2 to the power negative 1. So that means that this is going to give us the same answer of 2 to the 1 over 2. 1 over 2. So that is a negative exponent property, which when you have any number raised to the negative exponent, you can write it in a fraction form. So take note of that as well. Then we have the negative exponent of a rational function. What do I mean by negative exponent of a rational function? Now, if I have, let's say, a on b raised to the power negative n. Now, this expression can be written as b on a all to the power n. So from the negative exponent, when you find the reciprocal of the rational function in the bracket, it does away with the negative sign and it becomes b over a to the power n. Why is it so? So let's go back to the basics. From the basics, how come we had this becoming that? We have it as if I have a on b all to the power negative n. When we go to the negative exponent, we can write this as 1 over a on b all to the power n, because we have done away with the negative sign. So going back to class 1, just take a cool look at this. This is the same as 1 divided by a on b all to the power n. Now mathematically, if you have any number dividing a fraction, then you can change the division sign to become multiplication. But before that, perhaps someone may say that since we are having the power here, we cannot switch it. We can. This power over here is affecting each of the numerator as well as the denominator. So we can have it as 1 divided by a to the power n all on b to the power n. So in other words, it becomes 1 times b to the power n all over a to the power n. Therefore, we have it perfectly as b all over a all to the power n. So it actually explains that when you have any fraction raised to the power of a negative number, you can find the reciprocal of the fraction in the bracket, and then the negative exponent will be changed directly into a positive exponent. So this goes on and on and on and on. So let's take some examinable questions, and then let us use the laws and properties that we've looked at so far, and then we can actually do others later on. So to begin with, I have some SSE and WASSCE questions. I have 3 of them here. The first question says that evaluate 64 raised to the power 5 on 6. So evaluating 64 all to the power 5 on 6, we need to know our powers of numbers very well. So the question now is, what number can we write to a base for which it has a power of 6? The strategy is that I'm using a power of 6 for the fact that the exponent is a fraction which has a power of 5 on 6. So I'm thinking of a number that we can write 64 to a power of 6. And the best number is 2. 2 to the power 6 raised to the power 5 on 6. Now when you remember the power law, when you have a bracket separating 2 exponential factors, they can multiply. So we have 6 multiplying 5 on 6, and that will give us 5 left. So we have 2 to the power 5, and the final answer 2 to the power 5 is actually 32. Since the answers were left in the whole number form, then 2 to the power 5 is 32. So that is possible answer D. Now going to the next one, we are told that if 2 to the power negative n is equal to x, we should find 2 to the power n. That is also another nice question. 2 to the power negative n is equal to x. We should find an expression for 2 to the power n. Just that. Now remember, we learned that if you have a negative exponent, you can write it as 1 on 2 to the power n equal to x. So finding 2 to the power n, then it means we have to make 2 to the power n the subject. So a fraction equated to the variable x, then we can interchange or switch. Someone will say multiply through by 2 to the power n. So in doing that, we are just going to have 1 over x equal to 2 to the power n. And that is possible answer B. Moving on, we have 27. Simplify 27 to the power half times 64 raised to the power 1/3. Then divided by 81 to the power 1/4. So the question now is, can we write each of the terms there to a common base? Think about it. And the answer is no. You cannot write each of the terms there to a common base. Some of them can be written to a common base. Example is the 27 and then the 81. But for the 64, you cannot write it as a base which goes with the 81 as well as the 27. So how can we write 27 and to what base are we supposed to look for? Now 27 is not a perfect square, but all the same, we can write 27 as 3 to the power 3, and all this will multiply 1 over 2. Then the 64, since it's having a power of 1/3, we can write 64 as a base of 4, to the power 1/3. So we have it as 4 to the power 3 all to the power 1 on 3. Then dividing 81, we can write it as 3 to the power 4 all raised to the power 1/4. So we have some of them having the exponential law coming on board. So 3 to the power 3 times half will give us 3 to the power 3 on 2 times, now 4 to the power 3 all raised to the power 1/3 will give us 4, because 3 times 1/3 is going to be left with 1. So we have 4 to the power 1 divided by, we have 3 to the power 4 raised to the power 1/4. That will also give us 3 to the power 1, because 4 times 1/4 will be left with 1. So ideally, we can also have it as 3 raised to the power 3 or 3 on 2 divided by 3 raised to the power 1 multiplying 4 to the power 1. Now because the 3 raised to the power 3 halves divided by 3 to the power 1 has the same base, or have the same base, then it means we can subtract the power. So we have it as 3 to the power 3 over 2 minus 1 and times 4 to the power 1. Now when you simplify that, we are going to get actually 3.5 minus 1 is the same as 3 to the power half, because 3 on 2 is the same as one whole number, 1 over 2. Then minus 1, then we can take the 1 out and we be left with 3 to the power half multiplying 4. Therefore, we know that 3 to the power half is the same as square root of 3 multiplying 4. So finally, our answer becomes 4 root of 3. So there's possible answer D. Possible answer D. Let's go fast and then look at the other ones. So we have evaluate cube root of 2 to the power 6 all multiplying 5 to the power 3. And we have been asked to leave our answer in a prime factor form. So cube root is the same as raised to the power 1/3. So we have it as 2 to the power 6 multiplying 5 to the power 3 all raised to the power 1/3. Now you have the product of two prime factors all raised to the power 1/3. Therefore, the 1/3 will be affecting the factor 2 to the power 6 separately, and it will also affect 5 to the power 3 separately. So we are going to have it as 2 to the power 6 all to the power 1/3 multiplying 5 to the power 3 all to the power 1/3. So when you break it down, 6 multiplying 1/3 will be left with 2 to the power 2 multiplying 5 to the power 1, because 3 times 1/3 is the same as 1. And therefore, our final answer is 2 to the power 2 multiplying 5. And therefore, that is possible answer A. Moving on to the next, we have find the value of 16 to the power 1/4 times 125 to the power 1/3 and 27 to the power negative 1/3. If you look at it carefully, you realize that all those exponential functions cannot be written to a common base, but the powers will give you a clue as in to what power should you write each of the factors so that you can deal with the powers. So having 16 all to the power 1/4 multiplying 125 all to the power 1/3 multiplying 27 all to the power negative 1/3. 16 can be written as a base of 2. So that is 2 to the power 4 all to the power 1/4. Multiplying 125 can be written as a base of 5 to the power 3. So we have 5 to the power 3 all to the power 1/3. Multiplying 427, that will be a base of 3. So we have 3 to the power 3 all to the power negative 1/3. Now for multiplying, you see we are using the third law here, which is the exponential functions. So if you have a bracket separating two powers, then it means you can multiply. Then 2 to the power 4 times 1/4, which is the exponent, that will be left with 2 to the power 1. Multiplying 5, 3 multiplying 1/3 will also be left with power 1. Then that will also multiply, that of 3 multiplying negative 1/3 will be left with 3 to the power negative 1. Mathematically, as you know, when you have a negative exponent, you can write it in a fraction form. So we have it as 2 times 5, which is actually 10, times 1 on 3, which is the same as 10 on 3. So our possible answer is D. So far, so good. You can see that we are applying all the laws of indices as well as some of the properties. For instance, we had 2 to the power 1 is the same as 2, 5 to the power 1 is the same as 5. And then the property of the negative exponent, we are also using that as well. Now, this is a special case altogether. We having 4 to the power half plus 9 to the power half plus 16 to the power half, all raised to the power 2. Now, you bear with me that we never learned any law which combines two terms in terms of addition or subtraction. But we found out that all the laws were actually were coming out as a result of multiplication or division. So over here in our special case here, they are adding. We cannot add exponential functions of that nature. So what must we do? We try to simplify each exponential function, and then finally we add them where necessary. Now 4 to the power half, we can write 4 as a base of 2. So we have 2 to the power 2 all to the power half. Let me put it in square bracket, plus 9 can also be written as a base of 3. So 3 to the power 2 all to the power half, plus 4 to the power 2 all raised to the power half. Then the bigger bracket will be closed before the squared also comes on board. Now when you simplify 2 squared all raised to the power half, it will be left with 2 to the power 1, plus the same thing applies to the second term, which is 3 to the power 1. Then plus this will be left with 4 to the power 1. Then we close the bracket and square it. So 2 to the power 1 is the same as 2, 3 to the power 1 is the same as 3, 4 to the power 1 is the same as 4. So when you add 2 plus 3 plus 4 all raised to the power square, now that will give us an answer of 9 to the power 2. And 9 to the power 2 is simply 81. Therefore, our possible answer is C. Now let's move forward and look at other ones. As you know, the questions are becoming more complicated and complicated. So with this one, we have to evaluate 4 to the power 2/3 minus 49 to the power 2/3 and then 49 to the power 1/6, all divided by 1 on 7 raised to the power negative 7 on 6, multiplying 1 on 7 to the power 1/6. Now the numerator has a common base and they are dividing, therefore we can simply subtract their powers. So writing the question, we have 49 to the power 2/3 divided by 49 to the power 1/6, all divided by 1 on 7 to the power negative 7 on 6, multiplying 1 on 7 in bracket to the power 1 on 6. So dealing with the numerator, we are going to have a common base, which is 49 all to the power 2 on 3 minus 1 on 6. 2 on 3 minus 1 on 6, all divided by the denominator. It also has a common power, which is a common base, which is 1 on 7 raised to the power negative 7 on 6 multiplying. So in this case, we need to add. So we have negative 7 on 6 plus 1 on 6. So going forward, now 49 to the power 2 on 3. 2 on 3 minus 1 on 6. When we check it out, the LCM is going to be 6. We can do a side work. Let me do a side work here. And then, so I have 2 on 3 minus 1 on 6. The LCM is 6. 3 goes into 6. 2 times 2 is 4. Then we have 6 goes into itself 1 times that. So we have 1 minus 1. 4 minus 1. That gives us an answer of 3 on 6. So 3 on 6 can be broken as 1 on 2. So when we simplify the whole of 49 raised to the power that, we are getting 49 raised to the power 1 on 2. Now coming to the denominator, we can also work out the negative 7 on 6 plus 1 on 6. LCM is 6, so we have negative 7 plus 1. That will give me negative 6 on 6. That is negative 1. I believe we got in that. So the denominator is also going to be 1 on 7 all to the power negative 1. So moving forward, let me clean the operation that I had here. Moving forward, then we are going to have it as 7 to the power 2 all raised to the power half. Then we have the denominator as 7 raised to the power negative 1 all raised to the power negative 1. So we simplify, we have the numerator being 7 to the power 1 divided by 7 to the power 1. Now 7 to the power 1, you can use a quotient law, which is going to be 7 to the power 1 minus 1, which is 7 to the power 0, which is equal to 1. So the final answer is 1, which is possible answer B. Now, let me just move to the next question. Evaluate 2 to the power 0 plus 2 to the power negative 1 plus 2 to the power negative 2. You realize that they are being added, but they are all exponential functions. So we cannot just add them as it should be, but we can simplify each of them when necessary. So 2 to the power 0, we learned that it is 1 plus 2 to the power negative 1 is the same as 1 on 2 plus 2 to the power negative 2 is the same as 1 on 2 to the power 2, which is 4. So we have 1 plus 1 on 2 plus 1 on 4. Therefore, we need to find LCM. The LCM is 4. So we have this over 1. 1 goes into 4, 4 times that. We have 4. 2 plus 2 goes into 4, 2 times 1, we have 2. Plus 4 goes into itself 1 times 1, we have 1. When you simplify, you end up getting 4 plus 2, 6 plus 1, 7. So we have 7 on 4. 7 on 4 can also be written as 4 goes into 7, 1 whole number, 3 on 4. So the possible answer is D. Then let's go to our next question. The next question says that we should simplify the expression there. Now, you cannot use the calculator to get this answer, so you need to work out using your laws of indices as well as some of the properties to work things out. Now, if you look at it carefully, you realize that we have the bases as 8, 4, 2, and 16. All these numbers can be written in base of 2. So let's go straight ahead. Our question is, we should simplify 8 squared times 4 to the power n plus 1 all over 2 to the power 2n times 16. So as I said early on, we can write all of them to a base of 2. So we are going to have it as square root of 2 to the power 3 all to the power 2 times 2 to the power 2 all multiplying n plus 1. Then continuing, the denominator becomes 2 to the power 2n is maintained, and then we have times 2 to the power 4. Now when you simplify the numerator, since the bases are the same, then what are we going to have? The numerator is going to be 2 to the power 6, because 3 times 2 is 6, times 2 to the power 2n plus 2. Then the denominator will be 2 to the power 2n times 2 to the power 4. Now bringing them together, what can we have? Now the numerator is still going to be 2 to the power 6, because they multiply and have the same base, so we add the power. So 6 plus 2n plus 2 all over 2 to the power 2n plus 4, because the denominator also have a similar expression. Then moving on, we can actually, let's move up a bit so that we can have space for the operation there. So moving up a bit, then what are we going to have? Then in this case, we are going to obtain, I think I need to move up more. We are going to obtain square root of 2 to the power 6 plus 2n. Actually, we can make it 8. So 8 plus 2n, then minus 2n plus 4. Then that will be given as square root of 2 to the power. Now 8 minus 4 will give us 4. 2n minus 2n will give us 0. Now we can write this as 2 to the power 4 all raised to the power half. Therefore 4 multiplying half will give us 2. So we have 2 to the power 2. Therefore 2 to the power 2 will give us an answer of finally 4. So that is one way you could have done it. So let's go down and see what the possible answer is. So the possible answer is C, which is 4, which is 4. Possible answer C when you simplify. Okay, so you can actually go back and have a look at it, pause it, and then analyze the questions, and then you move on. So going further, we have another set of questions here. We have 1 on 16 all raised to the power negative half. We have to simplify it to 1 on 16 all raised to the power negative half. Then that is plus 8 on 27 all raised to the power 2/3. I don't know whether it's division sign or addition sign. So in other words, to work it out, if it's addition sign, we just have to simplify each of the expressions there. So 2 to the power 16, 1 on 16 can be written as 16 all to the power half. Then plus this will be written as, let me write it, 8 on 27 all to the power 2/3. Now you bear with me that the base 8 on 27 can be written as a base of 2 and a base of 3 all raised to the power 3. So in this case, the 16 can be written as 4 to the power 2 all raised to the power half, plus 2 to the power 3 all divided by 3 to the power 3 all raised to the power 2 on 3. Now going further, it will be left with 4 here, plus, what do we have here? This is going to be 2 on 3 all raised to the power 3. Then we can raise it to a power of 2/3. So going further, we have 4 plus, that is going to be left with 3 multiplying 2/3. It will be 2 on 3 all raised to the power 2. So when you simplify, you have 4 plus 2 squared is actually 4 all over 3 squared is 9. So when you find the LCM is going to be 9. 1 goes into 9, 9 times multiplying 4, 9, 4, we have 36. Then 9 goes into itself, 1 times 4, we have 4. So 36 plus 4 will give us an answer of 40 on 9. 40 on 9. So 40 on 9 is the same as 4 whole number 4 on 9, which we could have had the answer from this side. 4 whole number 4 on 9. So the possible answer is D. Now, this is an interesting question here. We should simplify x to the power negative 1 added to y to the power negative 1, all divided by x plus y. You remember, we cannot just work them out like that, but the best way of simplifying it is to write them as fractions. So we have 1 over x plus 1 over y all over x plus 1. Now, I can also rephrase it and then have it as 1 over x plus 1 over y all divided by x plus 1, so that I can easily work with the fraction. So LCM is xy. Now x goes into xy, y times multiplying 1, so we have y, plus y goes into xy, x times multiplying that, we have x. So the division sign can be changed to multiplication, so it becomes multiplying. And what do we do to the expression x plus 1? We write it as a fraction, so 1 over x, oh sorry, it is x plus y, so x plus y, so x plus y, so x plus y. Now, so the numerator will multiply 1, denominator will multiply 1. Remember, they are in the factor form. Y plus x is the same as x plus y. Therefore, x plus y goes into x plus y, and therefore it will be left with 1. So the numerator will be left with 1 over 1, 1 over xy, 1 over xy. So the possible answer is C. Then we go to the next, having 16 on 81 all raised to the power negative 3 on 4 times 100 on 81 all raised to the power 1 on 2. Now, we have a negative exponent here, so we can find the reciprocal of the fraction, and then we change the negative sign to addition. So it becomes 81 on 16 all raised to the power 3 on 4, multiplying 100 on 81 all raised to the power half. Now, going further, in order to get rid of the fractions for the powers, we can write the 81 as a base of 3 to the power of 4. So 3 to the power 4. And then the 16 can also be written as 2 to the power 4, all raised to the power 3 on 4. Multiplying, looking at the power of half, 100 can be written as 10 to the power 2, or divided 81 can also be written as 9 to the power 2, all raised to the power half. Now, they having a common power, then we can simplify by writing 3 on 2, all raised to the power 4. Then all must be raised to another power, which is 3 on 4, times 10 on 9, all raised to the power 2. Then we put it in square brackets, all raised to the power half. We are almost there. So let us move upwards a bit so that we can have space to do the remaining operation. This will be 4 times 3 quarter, and it will be left with 3. So we have 3 on 2 all to the power 3, multiplying 2 multiplying half will be left with just 1. So we have 10 on 9. So when we simplify, 3 to the power 3 is actually 27. And then 2 to the power 3 is also 8 times 10 on 9. When you simplify, 9 can go into 27 3 times, and then 2 can go into, so we breaking it down, we have 9 going into 27 3 times, then 2 will go here, 4, and it will go into 10 5. Now the numerator becomes 3 times 5, which is 15 on 4. 15 on 4, which is the same as 3 whole number 2 over 4. Sorry, 3 over 4. So because 4 goes into 15, 3, 4, 3, 12, then plus 3. So we have 3 whole number 3 on 4. Now let's check whether we have the possible answer 15 on 4 or 3 whole number 3 on 4. So we have 15 on 4, therefore that is possible answer C. Then we move on to our last example, which is not a subject, is a subjective question, which says that we should simplify square root of x cubed y to the power 5 all on xy to the power 7, where x is greater than 0 and y is also greater than 0. Now mathematically we can write the power of half as raised to the power, the square root as a power of half. So x cubed y power 5 all on x y power 7 can be written to the power of half. In this case, both the numerator and denominator, they have some common powers and some bases. So therefore, we can simplify them by saying that this is the same as x cubed minus 1, because the power of x here has a power of 1. Then times y to the power 5 minus 7, all raised to the power half. And that will give me x to the power 2 times y to the power negative 2, all raised to the power half. Now the half can be expanded through to affect the x as well as the y. So we have x squared, all raised to the power half, times y negative 2, all raised to the power half. So at the end of the day, 2 multiplying half will give us 1. So we have x to the power 1 times negative 2 multiplying half will be left with y to the power negative 1. So that is going to be x times 1 over y, which is finally given as x over y. So when you simplify square root of x cubed y to the power 5, all divided by xy to the power 7, you end up getting x over y. I believe you've actually had a very long form of examples when it comes to indices. It's a great privilege teaching you or taking you through some work examples. Kindly keep on learning and solve more work examples. If you've not subscribed to my channel, kindly do so to support the channel and share the videos. Your like, your subscription, your comments are all welcome. Thank you and have a nice day. God bless you.